Let's factorize quadratic trinomials where the coefficient of x squared is not 1. But factorizing quadratic trinomials where the coefficient of x squared is not 1 is a little more involved than the previous trinomials. Remember, in the previous section, we discussed about how we factorize trinomials where the coefficient of x squared is 1. What do we do if the coefficient of x squared is not 1? So I'm going to show you two methods. Okay, the first one is try and error, and then the next one I'll show you how to use factorizing by grouping in pairs. Right, let's consider this trinomial. You write down the first and the last term as products of their factors. So what is our first term? It is 21p squared. And then what is our last term? Is negative 4. You can even start by ignoring this sign. You can even start by ignoring the sign of negative 4 there. So the factors will be 21p squared. This can be 1p times 21p, isn't it? 1p times 21p will give us what? Will give us 21p squared. Or we can have 3p times 7p. And then negative 4, let's ignore the sign for now. So 4 will be 1 times 4. And then it can also be 2 times 2. It can be 2 times 2. And then what do you do after that? You can write these ones in columns like this. Let's have 21p squared. And then let's have 4. I said we're going to ignore the sign for now. Alright, we can have 1p, this one, and 21p. And then you have 3p and 7p. We're done with the factors of 21p squared. And then 4, we have 1, 4. Right, when it comes to the factors of the last term, these factors also must be written in reverse also. So we have 1, 4 and 4, 1. It's like 1 times 4 and 4 times 1. So for the second term, write the factors in reverse also. And then 2 times 2. 2 times 2 is fine. 2 times 2, even if reverse it, is still 2 times 2. So that's what you do, the first part. That's what we have. And then you try to look for the combination that will give you the middle term, 25p squared, when you cross multiply them. This is how you cross multiply. Let's start by trying this combination. I want to try this combination. 21p, you cross multiply like this. Okay, 21p and 1, and then 1p and 4. We want a combination that will give us positive 25. And then this negative 4 is very, very crucial. The sign here shows us that one factor is positive and then the other factor is negative. If the last term is negative, it means one factor is positive and then the other factor is negative. If the last term is positive, it means the factors have the same sign, like we discussed in the previous section. So now we cross multiply like this. So 1p, then 21p, 1, 4. If you cross multiply 21p times 21, 2, 21p times 1, that is 21p. 1p times 4, that is 4p. That one factor must be negative. If you check here, this combination cannot give us 25p. So you do the try and error till you get the right combination. Let's try the next one, the one that is going to give us the correct combination. So let's try this combination. I'll say 7p and 4, and then 3p and 1. Let's try that. 7p times 4, that is 28p. Then 3p times 1, this is 3p. This combination can give us 25. If this is negative 3, 28, and this one is positive 3. 28p minus 3p, that will give us 25p. positive 25p, which is our middle term here. See that? So this combination is the one. So now to get negative 3p, it means this one must be negative. So you have to insert the negatives to correct the combinations there. So it means this one must be negative, so that 3p times negative 1 will give us what? Negative 3p. And then what do you do after that? You read your factors horizontally. This is the factor, and then this is another factor. So you have your two brackets, 3p plus 4, and then 7p minus 1. We have factorized this. This is the method you can use. Let me show you the second method. The second method is almost similar to the method we use when factorizing quadratic trinomials, where the coefficient of x squared is 1. So what do? You multiply your first term and your last term. So in this case, it's going to be 21p squared times negative 4. Then what do you get? Negative 84p squared. Okay. When you're dealing with your factors, you can even start by ignoring the sign. And then you can insert the sign once you have found the correct combination. And then you can insert the sign once you've found the correct combination. So we multiply the first term and the last term. Okay, let's look at the factors of 84p squared. So it can be 1p times 84p. The combination must give us what? The middle term when we add them or subtract them. So this combination can give us 25p. Then we go to 2p times 42p. 2p times 42p is 84p squared. But this combination again cannot give us 25p. And then we go to 3p times 28p. Right, this combination can give us what? 25p. Remember, we said that if the last term is negative, it means that one factor is negative and the other factor is positive. And then this one confirms that the bigger factor is one which is positive. So it means this one is negative 3p, this one is positive 28p. And then what we do, we replace the middle term with these two factors. We replace the middle term with these two factors. So it becomes 21p squared. Okay, just ignore this part. We used this in the previous method. No? Okay, 21p squared plus 25p minus 4. We replace 25p with what? Negative 3p plus 28p, or positive 28p minus 3p. So it's 21p squared plus 28p minus 3p minus 4. So this and this is still one thing, because positive 28p minus 3p is still 25p, right? And then we factorize by grouping in pairs. The first pair, the common factor there is 7p, factor out 7p, 21p squared divided by 7p, that is 3p, positive 28p divided by 7p, that is positive 4. Right, we factorize the first pair, we come to the second pair now, we can factor out negative 1. Right, negative 3p divided by negative 1 is positive 3p, negative 4 divided by negative 1 is positive 4. Now we have two terms here with a common bracket. We can factor out this common bracket, which is 3p plus 4, okay? And then we take the coefficient of the bracket there, 7p, then we take the coefficient of this bracket, they form the second bracket. Actually, what you're doing, you are factoring out 3p plus 4. And then you say 7p times 3p plus 4 divided by 3p plus 4, you get 7p. Then negative 1 times 3p plus 4 divided by 3p plus 4, you get negative 1. You see that? So we have our two brackets here. We have factorized. This is how you factorize. Okay, let's do examples. We have 15x squared and 6y squared. So let's write 15x squared and then 6y squared. And then the factors for 15x squared can be 3x and 5x. Then can be 1x and 15x. And then for 6y squared can be 1y, then 6y. For the last term, we have to reverse the factors. So it's again 6y, then 1y. Then we can have 2y, then 3y, then 3y, then 2y. So we want a combination that will give us negative 19xy if we what? If we add them. Let me start with these two pairs. Right, I just want to check. If I cross multiply here, say 5x times 1y, I'll get 5xy. Then 3x times 6y, I'll get 18xy. 5xy and 18xy cannot give us 19 or negative 19xy. So I leave that combination. I go to the next one. What about this combination and this combination? If I say 5x times 6y, I get 30xy. Then 3x times 1y, I get 3xy. 30xy and 3xy cannot give us 19xy or negative 19xy. Let's leave that. Let's check the next one. Still on this one. And I go to this one now. Okay, let me see. Now 5x times 2y, I get 10xy. Then 3x and 3y will give me 9xy. Oh, this one can give us 10xy and 9xy can give us what? Can give us negative 19. So let's consider this one. If we don't get the correct combination, we have to try the next combination. So this one is try and error till we get the correct combination. So let's have our 3x and 5x and 2y and 3y. Don't worry about the signs for now. Just deal with the numbers without the signs. Then that is 5x times 2y, that is 10xy. Then 3x times 3y, that is 9xy. So if it's positive like this, means the same, they must be the same sign. If we add these, they give us negative 19xy. This is what we want. But now we have to insert the negatives. Yeah, so it's negative 2y here. So that 5x times negative 2y is negative 10xy, and then 3x times negative 3y is negative 9xy. So then we read our factors horizontally. These are the two factors, meaning that 15x squared minus 19xy plus 6y squared is equal to 3x minus 2y times 5x minus 3y. Let's do the second method. So 15x squared times 6y squared. 15x squared times 6y squared, which is equal to 90x squared y squared. Right? And then we look for the combination that will give us negative 19xy. Remember, when it's positive, means the factors have the same sign. Then negative, this one shows us that it is the same sign, which is what? Negative. It will be very easy to get this one, I think. You can try 1xy and 90xy. You go to 2xy and 45xy. You go to 3xy. You do that till you get the correct combination. And then 30xy. But 90x squared y squared can come from 10xy times 9xy. And then this combination is the one that can give us negative 19. If this one is negative and this one is negative, you see that? And then we replace the middle term with these two. Remember this method. We're going to factorize by grouping in pairs. Right, so it becomes 15x squared minus 10xy minus 9xy plus 6y squared. And then we factorize by grouping in pairs. Please revisit grouping in pairs if you forgot. What's the highest common factor here? It should be 5x for the first pair. 5x then becomes 3x minus 2y. Okay, and then For the second pair, we can factor out negative 3y, negative 3y, and then you get negative 9xy divided by 3, negative 9xy divided by negative 3y, you'll get positive 3x, and then positive 6y squared divided by negative 3y, you get to negative 2y. And then we have two terms here that have a common bracket, 3x minus 2y. We factor it out, 3x minus 2y. Then 5x times 3x minus 2y divided by 3x minus 2y, you get 5x. Negative 3y times 3x minus 2y divided by 3x minus 2y, you get negative 3y. And remember, I just said you can just take this coefficient and then this coefficient of the brackets and then form the second bracket. This is how we factorize a quadratic trinomial where the coefficient of x squared is not 1. Please don't forget that.